Hey everybody, so in this video I'm going to be doing a crypto challenge from the Cyber Apocalypse CTF 2022. I'm going to be doing Android in the middle, which here is the info if you want it. The clip notes for this challenge is basically we're going to use a kind of like basic mathematical property that's going to allow us to know what the shared secret key is, which we can then use to encrypt a message that when the server decrypts it matches what it's asking for, which will then give us the flag. So we get the source code for this challenge, which is what this is right here. And if you're watching this video, I'm going to assume that maybe you worked on this challenge and didn't get it. Maybe you got frustrated, or maybe you just looked at it and thought it looked confusing, but still kind of wanted to know what it was you were supposed to do. Maybe you're new to crypto. So what I kind of want to get at is, like, I think this challenge here is kind of a good example of there's a lot more going on than you really need to worry about. And if you just sort of focus on, like, narrow your focus down and kind of maybe go through even line by line, try to figure out what it is actually that you need to know, it can be like really helpful for solving it, or at least figuring out what it is you need to do, which is, especially with crypto, and good advice in, all areas of life, honestly, but crypto especially. And I think too, maybe because I think a lot of people tend to get intimidated with crypto just because they know there's math involved and it's supposed to be complicated. And for a lot of people, math is just something that, like, I know there's like anxiety or stress about, like, oh crap, math's involved. But yeah, so like that's kind of what I want to get at is, well, here, let's just actually go ahead and run this. So we see it's outputting a couple numbers. One's like really big and scary looking. The other one's just the number 2, and then it's asking us to enter in something. So if we look at this code, so kind of like the challenge itself is sort of centered around the Diffie-Hellman key exchange. But I'm not going to go over that for 2 reasons. One is you don't need to know anything about it in order to do this challenge. And 2, there's just way better resources out there to like explain it than whatever it is I would babble about. So that's kind of another thing too. Like, if you narrow your focus down and just go through, you'll see that like a lot of the stuff you don't even have to actually worry about. Now, maybe you learned a lot about Diffie-Hellman. You figured out that this involved the Diffie-Hellman key exchange. Maybe you learned a lot about it to try and do this challenge. Maybe that even like got you where you needed to do and you got the challenge, which is awesome. That's like the whole point of all the, CTFs in general, is like just learning stuff and having fun. And if you keep doing crypto, you're going to need to understand how Diffie-Hellman works. So good job. But basically, yeah, what was I going to say? Oh, let's just narrow our focus down. Like, we know that it's executing main, and if we look through a main and we see it's asking for something, we see that's this part right here. So let's just follow this through the code, right? And that's typically like good advice for, I don't know, hacking in general, is basically, what can I control, and let's follow it through the code. And that is what we're going to do here. So we see that what we enter is being converted into an integer, and if that conversion fails, the program exits. And that's just basically so we can't enter in gibberish. So basically it wants us to enter in an integer. And then we see that here, that integer is being put into this function, and the output's being stored in the shared secret. Now this function here is basically saying raise m to the power of c modulo p. And if you're not familiar with modular arithmetic, that's also something I'm not going to explain again, because there's just way better resources out there than what I would do. But modular arithmetic and like XORing are probably like the 2 most important kind of fundamental things in crypto to understand. So definitely go, if you're not familiar with it, learn about it. It's often like super short cliff notes is like one of the examples that's often used is like clock arithmetic. So basically like how 1700 hours is equivalent to 5 o'clock. So like 17 and 5 are sort of like the same thing. You can think of it like basically the numbers outside of on a clock, 1 to 12 don't exist. You can think of that the same way here, except in mathematicals it's actually 0 to 1 less than this number. Anything outside of that don't exist. I mean, they do, but whatever. So basically, we're taking whatever number we give it, we're raising it to the power of c, and we're doing that modulo p. And c here, if we looked, is basically just some random number between 2 and this really huge number. And there's no way for us to know what it is. And then this here is kind of, that deals with the whole Diffie-Hellman thing that we get to ignore. But so basically, this shared secret here, we're going to have control over, right? Because we control M, and we need to know the shared secret, because if you kind of work your way through the rest of the code, the other thing it's going to ask us for is to enter in some sequence, right? And it's going to convert it from hex, so that means we need to enter it in hex. It's going to convert that to bytes, and then it has to be divisible by 16. That's what this here is. So it needs to be evenly divisible by 16. So it's going to have to be 16, 32, 48, yada, bytes long. And what it's then doing with these two things we control, encrypted sequence and shared secret, is it's putting them into this decrypt function. And the output sequence is being compared to this phrase right here. And if that output matches this phrase, then we're going to get the flag. So basically that means what we need to do is figure out a way. We need to encrypt this so that when it's decrypted, it equals this. And so to do that, we need to know what the shared secret is. We can look at the decrypt function here. And so how do we know what the shared secret is? We know what P is, we know what M is, but we don't know this C. So if we gave it, like the number 42, there's no way for us to know how many times 42 is being multiplied with itself in order for us to figure out what this is. But let's just say we could. Let's say we know some trick and we could know the shared secret. Well, then the problem is basically boils down to we just need to encrypt. We just need to encrypt this phrase so that when it is decrypted, we get this back. And this is how it's encrypted. It's using AES ECB mode, which, again, stuff we don't need to know. But that shared secret key, that shared secret is being converted to bytes, because you have to, it's being hashed, basically. It's being MD5 hashed, and that's what's actually going to be the key in the AES function. So the trick then is, how do we figure out what shared secret is? And so you can try and go down and figure out how Diffie-Hellman works and how modular arithmetic works. But if we just think about it in its basic sense here, M to the power of C, we need to know what that is. Well, what's kind of like one of the things you often want to do when you're trying to figure out something with math or trying to figure out how it works is give it extreme cases and see what the effect that has. In math, often the most extreme case is what happens if I make it equal to 0. And so let's do that here. What happens if we make this equal to 0? We tell it our M, we're going to give it 0. Well, so then it's going to say 0 raised to the power of some number we don't know, modulo P, is going to be what? Well, what's anything times 0, right? Doesn't matter how many times we multiply 0 with itself, we're going to get 0. So that means if we give it 0, we know what the shared secret is. We could also use the number 1, right? 1 to the power of anything is always 1. The other thing you could actually do here is give it P. P, no matter how many times you multiply P, when you divide it by P to get the modulo, to figure out what, the other way modular arithmetic is often is like, the modulo operator, like what's the remainder? Well, p times p times p times p, however many times you want to do it, you divide that by p, there ain't going to be a remainder. You could use any multiple of p, 2p to the power of whatever, right? So like there's not good. So we could use 0, we could use 1, we could use p, but like the kind of extreme case that I think would be the easiest to come to on your own without maybe, knowing anything about modular arithmetic or Diffie-Hellman or anything might be just figure out what happens if you give it 0. And so if we do that, we know the shared secret is 0. So now we can actually figure out how to encrypt this code with that secret key so that when it decrypts it with that secret key, it gets this message back. So we see the secret key is being, or shared secret is being hashed. So we want to actually hash it ourselves. So we will say that the key is MD5. And so you always have to put in bytes. So we know we want it to, right? We want to encrypt, or we want to hash 0, because that's we know that M is going to be equal to when it gets passed in here. Or sorry, this shared secret is the integer 0. When you convert the integer 0 to bytes, you get that. That is the byte value 0. And then it wants the digest of it, which basically just means it wants it in bytes. And it helps if I put an equal sign. So our key is going to be these bytes. And then we can just encrypt it with AES, which again, you don't need to know anything about. You just need to import this stuff. If you're using Kali, I think the Python that comes with Kali has it. Otherwise, what you want to do is install PyCryptoDome. I think it's pip install PyCryptoDome, but don't take my word for it. Go Google that. But that's probably like if you're going to be doing crypto stuff, this is the package you're going to be using like over and over and over. It's like definitely going to want to have PyCryptoDome installed. So then let's just we're going to basically create our own encrypt function. We're just going to model it on this. So we will say that cipher, actually I can just copy and paste. So, and then in our message, which is going to be our ciphertext, is going to be, instead of decrypting, we are going to encrypt. We're going to encrypt that phrase, and it needs to be in bytes, and it is. So, and then we know that it wants it in hex because when we enter it in here, it's converting it from hex into bytes. So we need to convert that to hex. So basically, we want to tell it 0, and then we want to give it this message, which then it should decrypt, and we should get the flag, which we did. So hopefully that made sense. Again, my big hints would be just narrow your focus down, look at what it actually is asking for, and doing that can kind of help you block out all the other stuff that might like overwhelm your brain, especially if you're new to crypto. If you have any questions, like feel free to leave a comment. Like I'm always happy to help with and go on and on about crypto. So hopefully this video helped you, and yeah, thanks for watching.